And I wanna, could you be the one? Shh. Good, good. Good, good. Could you be the one?
A pleasant day to all of you. Today we'll be discussing about geometric series. All you have to do, guys, is please pay attention and listen. So let's start. Geometric series. When we say geometric series, this is the sum of the geometric sequences. The sum S sub n of the first n terms of a geometric sequence is S sub n equals a sub 1 times quantity 1 minus r raised to n all over 1 minus r, or S sub n is equals to a sub 1 times quantity r raised to n minus 1 all over r minus 1. We undergo derivation to get the second formula of a geometric series, where a sub 1 is the first term and r is the common ratio and r not equals to 1. So the reason why r not equals to 1, because once the value of r is 1, so the denominator will become 0, then the result will be undefined. Question number 1. Find the indicated sum of the geometric sequence. We have 8 plus 16 plus 32 plus, then we are going to find the S sub 6, meaning the sum of the sixth term. So a sub 1 equals 8. The common ratio is equals to 2. How did we get it? So simply divide 16 divided by 8. The answer is equals to 2. N is equals to 6, because we are looking for the sum of the sixth term. The formula that we are going to use is S sub n equals a sub 1 times quantity r raised to n minus 1 all over r minus 1. So we are using the second formula of a geometric series. So by substitution, we have now S sub 6 equals 8 times quantity 2 raised to 6 minus 1 all over 2 minus 1. Simplifying this, we have S sub 6 equals 8 times 6 quantity 64 minus 1 all over 1. Then the final answer now is S sub 6 equals 504. So that is the answer for question number 1. Let's proceed to another example. We have 4 plus 2 plus 1 plus ellipsis. So we're looking for the sum of the 12 terms, S sub 12. So the formula that we are going to use is S sub n equals a sub 1 times r raised to n minus 1 all over r minus 1. First, you are going to identify the given. A sub 1 equals 4. R equals 1/2. You just only divide 2 divided by 4 equals 1/2. Then n equals 12. Okay, the solution now we have S sub 12 equals 4 times quantity 1/2 raised to 12 minus 1 all over 1/2 minus 1. Then S sub 12 equals 4 times negative 4095 all over 4096. So we simplify 1/2 raised to 12 minus 1 So the result is negative 4,095 all over 4,096. Then the denominator will be 1/2 minus 1 equals negative 1/2. Okay, next. We have now S sub 12 is equals to negative 16,380 all over 4,096 divided by negative 1/2. Meaning, we multiply 4 to the numerator, 4,095. So that is why we have 16,380. Simplifying this, we have now S sub 12 equals 4,095 all over 512. So that will be the final answer in this question. Okay, next example. Find the sum of the first 6 terms of the geometric sequence 2, 4, 8, 16 ellipses. So A sub 1 equals 2, R equals 2, N equals 6 because we are looking for the first 6 terms. Then the formula is S sub N equals A sub 1 times quantity R raised to N minus 1 all over R minus 1. S sub 6 equals 2 times quantity 2 raised to 6 minus 1 all over 2 minus 1. Then this is equals to S sub 6 equals 2 times 64 because 2 raised to the 6th power, meaning you will multiply 2 6 times. So the result is 64 minus 1 all over 1. Simplifying this, we have now S sub 6 equals 126. So that is the answer for number 3 questions. So the sum of the first 6 terms is equals to 126. Okay, another question. Find the first 5 terms of the geometric sequence 3, negative 6, 12 ellipses. Again, find the value of A sub 1. So the answer is 3. R equals negative 2 because negative 6 divided by 3 is equals to negative 2. N equals 5. Since you are looking for the first 5 terms, then the formula still we're using formula number 2 here. By substitution, we have now S sub 5 equals 3 times quantity negative 2 raised to the 5th power minus 1 all over negative 2 minus 1. Then S sub 5 equals 3 times quantity negative 32 minus 1 all over negative 3. And then the value now, the answer is S sub 5 equals negative 99 over negative 3. Since the numerator and the denominator have a negative sign, so the final answer will be positive 33. So we need to simplify it. So that is the answer for question number 4. Number 5, last question about geometric series. Find the sum of geometric sequence for which the first term is 125, the last term is 1 over 5, and the common ratio is 1 over 5. Now, A sub 1 is equals to 125. A sub N, the last term, equals 1 over 5. R equals 1 over 5 also. Then N is the unknown. So we're looking for first for the number of terms here. Using the formula, A sub N equals A sub 1 times R raised to N minus 1. So by substitution, we have now 1 over 5 equals 125 times quantity 1 over 5 raised to N minus 1. And then we have now 1 over 5 raised to N minus 1 all over 1 over 625. Where did we get 625? We divide both sides of the equation by 125. So 1 over 5 divided by 125. So the answer is 1 over 625. Next is 1 over 5 raised to n minus 1 is equals to 1 over 5 raised to the 4th power. So we change the fraction 1 over 625 into exponential form. So it will become now 1 over 5 raised to 4, but they have the same value. 1 over 625 is equivalent to quantity 1 over 5 raised to the 4th power. Since they have the same base, so we will cancel it. So what is left will be, so cancel 1 over 5, 1 over 5. So it will become now n minus 1 is equals to 4. Transpose negative 1, so the answer now n equals 5. Then to find the sum, we will use this formula. So S sub 5 is equals to 125 times quantity 1 over 5 raised to 5 minus 1 all over 1 over 5 minus 1. Then S sub 5 equals 125 times quantity 1 over 3125 minus 1 all over negative 4 over 5. So we simplify 1 over 5 raised to the 5th power is equals to 1 over 3125. And then we have now S sub 5 equals negative 3124 all over 25 divided by negative 4 over 5. Simplifying it, the final answer is positive 781 over 5. Okay, thank you for listening. I hope you understand the how to solve geometric series by using the formula S sub n equals a sub 1 times r raised to n minus 1 all over r minus 1. Bye-bye! If you have questions, guys, feel free to send your questions or just send your questions in my email address, PISQ email address, official. Okay, thank you very much. Bye-bye!